In this video, we're going to cover some basic concepts such as displacement, velocity, acceleration, projectile motion, Newton's three laws, forces, momentum, and things like that. So for those of you who want a basic intro into physics and just want to understand some principal ideas involved in physics, this video is for you. So let's begin. The first thing we're going to talk about is distance and displacement. Now, many of you out there are very familiar with the word distance. When you think of distance, or when you hear the word distance, what do you think of? I think of how far something has traveled. So let's say the distance between one city to another could be 100 miles. And so it's the difference between 2 points. Now, displacement is very similar to distance, but displacement encompasses direction as well. Direction is important for displacement. So let me give you an example that distinguishes distance and displacement. So let's say if you have a person, let's say John, and he's at this position right here. And he decides to walk, let's say, 8 meters east. And then he turns in the other direction and travels, let's say, 3 meters west. The total distance that John travels is 8 plus 3, or 11 meters. However, his displacement is not 11, but rather his displacement is 5 meters. Displacement is the difference between the final position and the initial position. So let's say if we have a number line, and let's say this is position 0. So John traveled 8 meters east. So now he's at position 8 on a number line. So during the first part of his trip, his displacement was positive 8. Then he traveled 3 meters west. So his displacement is negative 3. So now he's at position 5. And so his net displacement is 5 meters because he started from position A and now he's at position B, which is located at position 5. And so your net displacement is basically, it's the final position, let's say PF, minus the initial position. His final position is position 5. His initial position is 0. So his displacement is positive 5. He went from A to B. And so that's the basic idea behind displacement. The total distance is 11. Now, distance is a scalar quantity. It only has magnitude. Displacement is a vector quantity. It has both magnitude and direction. In the case of distance, in the first part of the trip, he traveled a distance of positive 8. In the second part, he traveled a distance of positive 3. And so the total distance is 11 meters. Now, displacement has magnitude and direction. During the first part of his trip, his displacement was positive 8. The magnitude is how far he traveled, which is 8 meters. The direction is he's traveling east, and so we have a positive sign for going in an eastward direction. Anytime you're going towards the right, you're going in the positive x direction, so the displacement is positive. Now, during the second part of the trip, he's traveling west, that is towards the negative x direction. And so it's negative 3 in terms of displacement, but in terms of distance, it's positive 3. Keep this in mind. Distance is always positive, but displacement can be positive or negative. If you're traveling east or north, displacement has a positive value. If you're traveling west or south, displacement has a negative value. And so if you add up the displacement for the first part of the trip, plus the displacement of the second part, you get the net displacement of positive 5. Positive 8 plus negative 3 will give you positive 5. Now let's say a car travels 200 miles. Would this description be related to distance or displacement? So if I say you travel 200 miles, am I describing distance or displacement? Well, this would be a description of distance because no direction was indicated. So you could be going east, west, north, or south. If you simply state 200 miles, you're describing distance. Now let's say if the car traveled 300 miles north. In this case, I have the magnitude, which is 300 miles, and I also have the direction, which is in the northward direction. So in this case, I'm describing displacement. Displacement is a vector quantity. It has both magnitude and direction, whereas distance is a scalar quantity. It only has magnitude, such as 200 miles, without any direction. So make sure you understand the difference between a scalar quantity and a vector quantity. A scalar quantity, as we said before, has magnitude only, but a vector quantity has magnitude and direction. Now let's talk about speed. When you think of the word speed, what do you think of? Speed tells you how fast something is moving. So let's say if a car is traveling 30 meters per second. What does that mean? So that means that every second the car will have traveled a distance of 30 meters. So let's say this is the starting line, and I'm going to use a box to represent a car. And the car is moving in this direction with a speed of 30 meters per second. So 1 second later, the car will have traveled a total distance of 30 meters. 2 seconds later, it's going to travel another distance of 30 meters, so for a total distance of 60 meters. So we can make a table. So let's put T for time, D for distance. So if the speed is 30 meters per second, so every second the distance traveled will increase by 30. And so that's what speed tells us. It tells us how fast the distance of an object or the distance traveled by an object is changing every second. So let's say if you're driving a car and you're going 60 miles per hour. Every hour at that speed, you will travel a distance of 60 miles. So let's say if you want to travel a distance of 300 miles. It's going to take you 5 hours to do so. In the first hour, you're going to travel 60 miles. In the second hour, you have covered a distance of 120 miles. So every hour, you're going to travel an additional distance of 60 miles. Now, there's a formula that you need to know, and it's D is equal to VT. In this equation, D can be used as distance, and V represents speed, T represents time. Now sometimes with this formula, you could use the velocity in terms of V. And if you do so, then D will no longer technically be represented by distance, but it's going to be represented by displacement. And so you could use that simple formula in many different ways. So here's a question for you. So let's say if you have an object that is moving at a speed of, let's say, 50 meters per second. How long will it take for this object to travel a distance of 1,000 meters? So we're looking for the time, how long? So we could use this formula, D is equal to VT. So the distance is 1,000 meters, V is 50 meters per second, and we need to calculate the time. So we can divide both sides by 50. And so it's going to be 1,000 divided by 50. If we cancel a 0, that's 100 divided by 5, which is 20. So it's going to take 20 seconds for this object to travel a distance of 1,000 meters. Now let's talk about speed and velocity. So what is the difference between these two quantities? Because they both describe how fast something is moving. But there's a difference between them. Speed is a scalar quantity and velocity is a vector quantity. Speed is always positive. Velocity can be positive or negative. Now recall that a scalar quantity only has magnitude, whereas a vector quantity has magnitude and direction. So can you think of some examples that will distinguish speed from velocity? So let's say if a train, I'm going to use a box again, is moving at 45 meters per second. Let me take away the arrow. So you don't have any direction. It's simply moving at 45 meters per second. In this case, this describes the speed of the train because I'm telling you how fast it's moving, but not where it's going. Now, let's say if we have a train moving at 30 meters per second going west. In this case, this is a description of velocity because not only do you have the magnitude of the vector, which is the speed, but you also have the direction. And so when you combine magnitude and direction, you have a vector quantity. And so velocity is basically speed with direction. The 30 meters per second tells you the speed, west tells you the direction, and when you combine these two, you have velocity. So let's summarize a few key points. Speed tells you how fast something is moving. Velocity tells you not only how fast something is moving, but also where it is going. So remember, velocity is speed with direction. Speed can only be positive. Velocity can be positive or negative. So if v is negative 20 meters per second, you know you're dealing with velocity because it's negative. If you're looking for the speed would be positive 20 meters per second. Speed is always positive. And you could say that speed is the absolute value of velocity. Velocity can be positive or negative, but speed is always positive. So if the velocity was negative 35 meters per second, the speed is automatically positive 35 meters per second. Now, there are some mathematical formulas that you want to know when dealing with speed and velocity. There's something called average speed. Because sometimes in physics you need to calculate the average speed of an object. The average speed can be calculated by taking the total distance traveled by the object and dividing it by the total time. Now, if you think about this formula, d is equal to vt. V can be described as the speed or the velocity. So if you divide both sides by t, you could cancel this on the right side. You'll see that v, which is the average speed in this case, is equal to d over t. So average speed v is equal to the total distance d divided by the total time t. Now what about average velocity? Let's say if we wish to calculate average velocity, how can we do so? Average velocity is equal to displacement divided by the total time. So in this case, the formula looks the same. Average velocity could be represented by v, displacement can be represented by d, and the time is t. So the formula looks identical, but the meaning is different. So keep this in mind. Velocity is associated with displacement. Speed is associated with distance. Now let's say if you have an object and this object traveled 12 meters east and then it travels 20 meters west. And it did so in a total time period of 4 seconds. So let's say going from position A to position B, that's a distance of 12 meters, and from position B to position C, 20 meters. So that total trip from A to C took only 4 seconds. So for this object going from A to C, what is the average speed of the object? And also, what is the average velocity? So to calculate the average speed, we need to determine the total distance and divide it by the total time. The total distance is simply 12 plus 20. If you add those two numbers, it will give you 32 meters. And the total time is 4 seconds. So 32 divided by 4 is 8. So the average speed is positive 8. Keep in mind, speed is always positive. Now what about the average velocity? Well, we know that average velocity is defined as displacement divided by the total time. The displacement for the first part of the trip going from A to B is positive 12 because the object is traveling in a positive x direction. The object is going east. For the second part of the trip, the object is traveling west towards the negative x direction. And so going from B to C, the displacement is negative. So if we add up 12 and negative 20, we can get the net displacement, which is negative 8. Now keep in mind, you can also treat this as a number line. Let's say A is at position 0. B will be at position 12. And then if you do 12 minus 20, you'll see that C is at position negative 8. And the difference between these two positions will be the net displacement, which is still negative 8. So the final position minus the initial position will give you the net displacement. Now let's divide it by 4 seconds. So the average velocity is negative 2 meters per second. And it makes sense because the net result is that the person traveled in the westward direction towards the negative x-axis. So going from A to C, ignoring B, the person traveled towards the west. And that's why the velocity is negative, because anytime you're going in the west direction towards the negative x-axis, it will be negative. If you're going towards the positive x-axis or in the eastward direction, it's going to be positive. Now let's talk about acceleration. What is acceleration? Now, you've encountered acceleration when driving a car. A good way to think about it is imagine two vehicles. Let's say a truck I'm not the most artistic person, but we'll work with this. And let's say a sports car. Which of these two vehicles have, let's say, a greater acceleration? Is it the truck or the sports car? So what is acceleration? Acceleration tells you how fast the speed is changing, or more technically, how fast the velocity is changing. So the truck can probably go from 0 to 60 miles in maybe, let's say, 30 seconds. A sports car can go from 0 to 60 in a shorter period of time, let's say in 5 seconds. So because the sports car can get to a higher speed or to a certain speed faster than the truck, it has a greater acceleration. And so acceleration tells you how fast the velocity is changing. Acceleration is defined as the change in velocity divided by the change in time, or sometimes you could just put t. So you can write it this way. Let me adjust the formula. So if you see the triangle, it simply means change. So acceleration can be written this way. It's the final velocity minus the initial velocity divided by the time. So to calculate the acceleration of the truck, notice that the change in velocity is 60. 60 minus 0 is 60, divided by the time, which is 30. So 60 divided by 30 is 2. So the acceleration of this truck is 2 miles per hour per second, because we divided miles per hour by seconds. So it's miles per hour per second. Now, the acceleration of the sports car is 60 miles per hour. That's the change in velocity divided by 5 seconds. 60 divided by 5 is 12. So it's 12 miles per hour per second. As you can see, the acceleration of the sports car is much greater than the acceleration of the truck. The truck is going to take a long time to go from 0 to 60, but the sports car will get there a lot faster, and so it has a greater acceleration. And so that's the basic idea behind acceleration. It tells you how fast the velocity is changing. Now let's make a table. Let's say if an object is moving with an initial speed of 12 meters per second. So VO tells you initial speed or initial velocity. Now, since I have an arrow, let's say it's going east, this now it becomes the description of velocity if I put direction with it. And let's say at this point, this object or vehicle begins to accelerate at a rate of 4 meters per second squared. So this is 4 meters per second per second. So what does that mean? So if we make a table, if we plot time and velocity, let's say the final velocity at a certain time, at t equals 0, this becomes the initial velocity, so it's 12. What will the velocity be 1 second later? Well, the acceleration tells us how fast the velocity is changing. So because the acceleration is positive 4, that means that the velocity is increasing by 4 meters per second every second. So anytime acceleration is positive, the velocity is increasing. Anytime the acceleration is negative, the velocity is decreasing. So 1 second later, the velocity will now be 16. 2 seconds later, the velocity is 20. 3 seconds later, it's 24. 4 seconds later, it's 28. And so every second, the velocity will increase by 4 meters per second because the acceleration is 4 meters per second per second. Now, the formula that you want to use to calculate final velocity is this equation. V final is equal to V initial plus AT. Now, let's say we have another object that is moving in an eastward direction at a speed of, let's say, 24 meters per second. But this time, let's say the acceleration is negative 6 meters per second squared. What's going on here? Is this object speeding up or slowing down? Whenever the acceleration and velocity, whenever they have opposite signs, the object is slowing down. Whenever they have the same sign, it's speeding up. In the last example, the acceleration was positive 4 and the velocity had positive values. it started with positive 12. And so because velocity and acceleration have the same sign, the object was speeding up. So you may want to write this down. The object will be speeding up, that is, the speed will be increasing if acceleration and velocity have the same signs, if they're both positive or if they're both negative. The object will be slowing down if the acceleration and velocity have opposite signs, either positive and negative or negative and positive. And this example will illustrate that. So this time, we're going to make a table with time, velocity, and I'm going to use S for speed, or SP for speed. So at t equals 0, the velocity is positive 24. And remember, speed is the absolute value of velocity. So the speed is positive 24. Now 1 second later, what will be the new velocity? Well, the acceleration is negative 6. And recall that if acceleration is negative, the velocity will be decreasing. So it's going to decrease by 6. So 24 minus 6 is 18. 2 seconds later, it will be 12. 3 seconds later, it's going to be 6. 4 seconds later, it's 0. 5 seconds later, it's negative 6. And then so forth. Now, speed is always positive. It's the absolute value of velocity. So here the speed is positive 18, positive 12, positive 6, 0, positive 6, positive 12, and so forth. Now, let's focus on the first half. In the first 4 seconds, the object is slowing down. If you look at the speed is decreasing from 24 to 0. So what's happening is that the object is moving, but over time, it's moving slower and slower and slower. And so at 4 seconds, at that instant, it's not moving. However, it's changing direction. Notice the velocity. It's going from positive to negative, which means that it's changing from an eastward direction to a westward direction. And it begins to move faster towards the west. So as you can see, it's speeding up because the speed is increasing after 4 seconds. Now remember what we said before. If acceleration and velocity, if they share the same sign, then the object will be speeding up. That is, if they're both positive or both negative. But if they have opposite signs, then the object is slowing down. So during the first 4 seconds, the velocity is positive and the acceleration is always negative. Therefore, because the signs are opposite, it's slowing down. The speed is decreasing from 24 to 0. Now, during the second part of this problem, that is after 4 seconds, the velocity is negative and the acceleration is negative. So because they share the same sign, the object is speeding up. As you can see, the speed increases from 0 to positive 18 in the next 3 seconds. So make sure you understand that concept. If acceleration and velocity share the same sign, the object is speeding up. If they have opposite signs, it's slowing down. Now let's move on to gravitational acceleration. In physics, you'll see this symbol that looks like a G, and it's equal to negative 9.8 meters per second squared. So this is the gravitational acceleration of planet Earth, and it varies for different planets and other very large objects. So the gravitational acceleration of the moon, for example, is negative 1.6 meters per second squared. It's a lot less. For one reason, the moon has less mass than the Earth. And so you will weigh a lot less on the moon. You'll feel lighter on the moon, and so you can jump higher on the moon. But let's focus on the gravitational acceleration of the Earth, negative 9.8. What does that mean? Well, in the last example, we saw what a negative acceleration can do to velocity. And so the fact that this gravitational acceleration is negative means that it will always decrease the velocity. Now, the gravitational acceleration of the Earth, it acts in the y direction and not in the x direction. And so let's talk about velocity. Velocity is a vector, and it can have an x component and it can have a y component. The actual velocity is basically the hypotenuse of this right triangle. Vx is the horizontal component of this velocity vector. Vy is the vertical component. The gravitational acceleration does not affect Vx. It affects Vy. So technically you can write this as Gy. It's a vertical gravitational acceleration. It doesn't affect the horizontal velocity, it affects the vertical velocity. So make sure you understand that. Now let's use an example to help us understand Gy. Sometimes it could be written as Ay. So Ay and G are basically the same. It's negative 9.8. Let's say we have a person who is standing on top of a cliff next to the ocean, and this person has a ball in his hand, and he released the ball from rest. So he doesn't throw it down or throw it up, he simply lets go of the ball. Well, we know what's going to happen. Gravity is going to cause the ball to fall. Now, what can you tell me about Vy, the vertical velocity of the ball? Over time, will it become positive or negative? Well, we know that velocity is speed with direction. And right now, the ball is going to be moving in the negative y direction. So this is positive x, this is negative x, positive y, negative y. It's going down in the negative y direction. So Vy will become negative. If we make a table with t and Vy, at t equals 0, the initial vertical velocity will be 0 because the ball was released from rest. Now the acceleration, or also called acceleration due to gravity, is negative 9.8. Because it's negative, the vertical velocity will be decreasing. So every second, it's going to decrease by 9.8. So 2 seconds later, it's going to be negative 19.6. 3 seconds later, it's negative 29.4. Now the speed is always going to be positive. So if you were asked, what is the speed of the ball? Let's say 3 seconds later, it's going to be positive 29.4 meters per second. But if a test question asks you for, let's say, the velocity of the ball 3 seconds later, you should say it's negative 29.4 meters per second because it's going in the negative y direction. And so hopefully this number makes more sense. So the gravitational acceleration tells you how fast the vertical velocity is changing every second. So on the moon, where G is negative 1.6, if you were to drop a ball, the vertical velocity will decrease by 1.6 meters per second every second. So let's say we have a similar situation. We have the same person with the ball in his hand, and this time he throws it in the upward direction with an initial speed of 29.4 meters per second. What can you tell me about the vertical velocity and its values every second? And let's say this person is still on the Earth. where g is negative 9.8 meters per second squared. So even though right now the velocity is positive, because g is negative, the vertical velocity will decrease. So as the ball goes upward, it's slowing down because the velocity is positive and the acceleration is negative. Because they're opposite in sign, the ball is slowing down. Eventually, the ball will reach its maximum height, and then it's going to change direction and begin to fall down. So if we make a table between t and Vy, we're going to get the following values. So at t equals 0, that is initially, the vertical velocity is positive 29.4. Now the acceleration tells us how fast or how much the velocity changes every second. So 1 second later, it's going to decrease by 9.8. So 29.4 minus 9.8 will give us 19.6. So 1 second later, it's going to be positive 19.6. 2 seconds later, we'll need to decrease this again by 9.8. So it's going to be positive 9.8. 3 seconds later, it's going to be at 0. So when the vertical velocity is at 0, that means that it's no longer going up anymore. And it's not going down yet. It has reached its maximum height. So it took 3 seconds to get to its maximum height. So let's call this position A, position B, and position C. So when t is 0, it's at position A. When t is 3, it's at position B. 4 seconds later, it's going to be negative 9.8. 5 seconds later, negative 19.6. 6 seconds later, negative 29.4, and so forth. And so once it gets to position B, once it passes that position, the velocity will be negative because it's now going in the downward direction or in the negative y direction. So that's the mathematical profile of this situation. So now you understand what's happening to the velocity values as time progresses. So anytime the acceleration is negative, the velocity is decreasing. As you can see, it started with a positive value, and now it's becoming negative. Now the next topic that you want to be familiar with is something called projectile motion. So what is a projectile? A projectile is basically an object that is moving under the influence of gravity. So in the last two examples, the ball that was released from rest and the ball that was thrown upward were behaving as projectiles because once released, they were under the influence of gravity. And in a typical physics course, when dealing with projectile motion, friction is usually ignored. And so we're not going to talk about it here. So far, we've considered one-dimensional projectile motion, that is, in the y direction. The first case was a ball going straight down. The second case was the ball going up and then down. So it's one-dimensional because it's only one direction, in this case the y direction. But let's talk about projectile motion in two dimensions, that is, in the x and in the y direction. So one example that you'll see is a ball being kicked off a cliff or rolling off a cliff. Initially, it's moving in the x direction and then it falls down like this. And so the path that the ball travels is known as the trajectory. Hopefully I said that right, trajectory. But now let's say the ball was kicked off the cliff at a speed of, let's say, 5 meters per second. So what can you tell me about the vertical and horizontal components of the velocity of the ball at different times? So let's make a table between t, vx, and vy. So initially, when t is 0, Vx is positive 5, because at that instant, it's moving only in a horizontal direction. So if you look at the trajectory, this line is only going to the right. It's not going up or down, it's just going to the right. Now, the vertical velocity is 0 because it doesn't have any component in the y direction. Now 1 second later, let's say the ball is over here. So now the ball is moving in this direction. So the velocity can be broken up into its x component, so it's still moving to the right, and the y component, it's moving down. So let's call this point A and that point B. So at point B, because it's going in this direction, it has a Vx value and a Vy value. And let's say point B is 1 second later from point A. So point A, t is 0, and at point B, t is 1. So what is the velocity at point B? And what is the velocity at point C, let's say, where t is 2 seconds? 1 second later, we know what Vy is going to be. Due to gravitational acceleration, the vertical velocity will decrease by 9.8 every second. So 2 seconds later, it will be negative 19.6. 3 seconds later, negative 29.4. Now what about Vx? Now it's important to understand that g, negative 9.8, is a vertical acceleration, not a horizontal acceleration. It's not it's not ax, but it's ay. So this number does not affect Vx. So when dealing with projectile motion, unless this ball has some rocket thrusters, Vx is constant. It doesn't change. So for projectile motion, the acceleration in the horizontal direction is 0. So unless there's some kind of force that's propelling the ball to the right, that is after it's been kicked, ax is 0. So it's important to keep that in mind. And if ax is 0, that means that Vx does not change. If the acceleration is 0, the velocity is not changing. The velocity is constant. So to summarize what we've learned here, when dealing with projectile motion, it's important to understand that the velocity in the x direction, Vx, is constant. It doesn't change unless the problem states that there's something accelerating it in a horizontal direction. If there's no specific statement as such, ax is 0 and Vx is constant. But for any projectile motion problem, Vy changes. Vy is going to change by 9.8 every second. Here is another projectile motion situation. Let me start at the bottom. So let's say we have a ball, and the ball is kicked off the ground at an angle. It goes up, and then it goes down. Now typically, you might be given the velocity at which it's kicked. Let's say it's going up at a speed of 40 meters per second, and let's say it's at an angle of 30. So you have v, which is 40, and you have the angle theta, which is 30 degrees. Now what you need to do is find Vx and Vy. Vx is basically v cosine theta, and this is the initial value. Vy is v sine theta. Now for this problem, I'm going to give you Vx and Vy. So we're going to choose some different values, but in a typical problem, when you're given v and theta, you can find Vx and Vy using those formulas. But let's say that you discover initially Vx is, let's use a nice number, 8 meters per second. And Vy, we're going to say is 29.4 meters per second. So that's at a time value of 0. What's going to happen 1 second later? So 1 second later, what's going to happen to Vx and Vy? Now, it's important to understand that Vx will not change for projectile motion. Gravity does not affect Vx, it affects Vy. So 1 second later, Vx will still be 8 meters per second. Vy is going to decrease by 9.8 meters per second every second. Gravitational acceleration affects Vy, but not Vx. So this is going to be 19.6 1 second later. Now, 2 seconds later, Vx will still be the same, and that's 8 meters per second. Vy is now 9.8. 3 seconds later, it's at the top. At the maximum height, at the highest point, Vy is 0, so it's not going up anymore, but it's still moving to the right. So it's still moving at 8 meters per second to the right, so that's Vx. Now, 4 seconds later, what do you think is going to happen? Well, Vx is still the same. It's still 8 meters per second, but now it's going down. So Vy is negative 9.8. And then 5 seconds later, Vx is still the same, but Vy is now negative 19.6. And 6 seconds later, Vy is going to be negative 29.4. So notice that the speed is the same when the height is the same if the trajectory is symmetrical. In this case, the left side looks exactly the same as the right side. So there's symmetry for this type of shape. So at a certain height, Vy has the same magnitude but the opposite sign. This is positive 19.6 and that's a negative 19.6. So the velocities just have opposite signs, but speed in either case is still positive 19.6. So the speed is the same when the height is the same. But Vx doesn't change in a typical projectile motion problem. Only Vy changes based on the gravitational acceleration. Now let's talk about Newton's 3 laws. So let's go over the first law. The basic idea behind Newton's first law of motion is that an object at rest will remain at rest unless acted on by a force. And an object in motion will continue in motion unless acted on by a net force. So let's say if we have a box and it's at rest, it's not moving. The only way we can get this box to move is by applying a force. And a force is a push or pull action. So in this case, the force is pushing the box towards the right. We can also get the box to move towards the right if we take a rope and pull the rope towards the right. So here this is a push action, and towards the right it's a pull action. And the way to pull something is by means of a rope. Whenever you have a force acting on a rope, it's known as a tension force. So whenever you hear the word tension, it's basically a force acting through a rope. So unless we apply a force, the box at rest will continue to remain at rest. Now let's say we have a box, and this box is moving to the right. So it's sliding across this surface. The only way to stop the box from moving in this direction is to apply a force in the opposite direction. And friction will do that too. So if you try to slide a box across a rough surface, you know the box is going to come to a stop because friction will oppose the box from moving. Friction always opposes motion. It tends to slow things down. And so thus we have Newton's first law. An object in motion will continue in motion unless acted on by a force. So if there was no friction, this box will continue to slide forever. But because friction is present and it's opposite to the direction of the velocity of the box, it's going to slow it down and bring it to rest. So if that force wasn't present, it will keep moving. So if you think of objects moving in outer space where there's almost no friction, those objects tend to basically move forever. So if you think of the Earth as it revolves around the sun, the Earth moves in a vacuum of space. It's basically almost no air in space. And so there's hardly any friction. Thus, it can move forever around the sun without any or hardly any assistance. A good way to illustrate this is, imagine if we take an object and, let's say like a puck, if you're playing air hockey, and if we slide it across ice. Because there's not much friction between this object and ice, because ice has a very smooth surface, this object will travel for a very long time because there's not much friction between the ice and this object. Whereas, let's say if you have the same object across a rough surface, this object will not slide very far. It's going to come to a stop quickly because there's more friction. And so if you can reduce friction, the object will travel for a very long time. And if you can completely eliminate friction, then by Newton's first law of motion, it should continue forever. So an object in motion will continue in motion unless acted on by a force. Now let's talk about Newton's second law. And the best way to summarize Newton's second law of motion is through this equation. The net force of an object is equal to the mass times the acceleration. And sometimes you'll see the term net force written this way, as with a summation symbol, or sigma. And this could be the net force in the y direction or the net force in the x direction. Nevertheless, just make sure you understand that the net force is basically the mass times the acceleration. So here's a question for you. Let's say if I have a 10 kilogram mass and it rests across a horizontal surface, and let's say there's no friction, and I apply a force of 80 newtons. What is the acceleration of the box? So F equals ma. The force is 80 newtons. The mass is 10 kilograms. What is A? So A is going to be 80 divided by 10, which is 8. So this box will accelerate at 8 meters per second squared. So what does that tell us about the velocity of the box? So every second, the velocity of the box will increase by 8 meters per second. So if we make a table, at t equals 0, the velocity is 0. When t is 1, the velocity is 8. When t is 2, the velocity is 16, and so forth. And so whenever you apply a force on an object, you exert an acceleration on that object, and as a result, you're increasing the velocity of that object. That object will begin to move at a faster pace.